or like get a basic implementation of the gravity system that I was working on working. So today I'm going to kind of polish up the default assets from that so that they give visual indication of um, what the gravity is going to do. And to do that, I think we're going to need to make at least one texture here. I'm going to go ahead and turn off the background. Create a new layer. And let's go ahead and create like an arrow material. Let's take a look. Hang on. Or we could just search it. That's not a bad idea either. PG. Uh, Something like this. I'm just looking at ideas here. Something like. Actually, kind of like that. Or. You gotta think that we're gonna be like replicating this and it's gonna have a panner, so maybe having it be asymmetric is not good. Even something like this. Okay. Okay. One there. And over here. What? That's not right. I mean, I guess it doesn't really have to be perfect. 3 hundo. 1024 would be 512. So 512 is our center point. And now, okay, let's alpha to selection. Select shrink by 10. Select invert. Delete. Duplicate. Okay. And then merge visible. Duplicate. We'll do like six. Six stripes. And duplicate. That looks pretty good. And then let's just layer merge visible. Let's see. So 520, 512, 1024, 512, 256. I will set one of these at 256. One of these at 256. Maybe. Come back to that. This one would be 12, 7, 512 plus 256, 7, 768, 512, 256, 768. Yeah. All right. And then let's just put one right here and right here. Make our selection. Control X, Control V, new layer, new layer, get rid of this. Then we want our transform layer tools. Well, they'll like transform tool though. Hey, Jinx. Okay, width will be 1024, height will be 1024. Unlock. That's good. Finally, let's do one more thing. Select. Shrink 5 pixels. Select invert. Transparency. Undo bucket. We will export this into the gravity folder. Import it. Hello. All right. So yesterday, right before I went to bed, I was just fucking around, but I went ahead and hang on, let's do this. If you'll notice, I've added a BP gravity, the gravity component to these little blue cubes to test the static mesh stuff, and it just works. So we can go over here when you see that one falling because it's in that gravity zone. If I punt this into that gravity zone, it'll fall too. If I punt this one in, it'll fall too. We go in, we get flipped, we fall. We can maybe punt one back to the sphere over here. Maybe. Nope, I missed. It's okay, don't worry. That guy's gonna end up on the planets uh, under the level. So, punt this one at the sphere too. Alright, we'll jump on the sphere, punt them off, jump over here, punt them off the stage. You land on this guy. Eventually he'll land. He's kind of in a pseudo orbit right now. Yep, he's landing. And we can also use our little gravity elevators that I made yesterday. Though I kicked it out of the range that the gravity elevator operates on. So it's not going to properly get over there until it lands again. Uh, but now I want to, I might make a plugin out of this. So I want to go ahead and polish up the example gravity zones, which are the box and sphere simples. And I want to add some gravitational indicators to them. So yeah, we can kick it into the gravity elevator, gravity field, and it'll get shot back over to there. All right, so materials. Let's actually get rid of this. Let's rename this gravity direction indicator. Sample. Make this an additive. Something like this. So, vector, parameter, color. We can flip to divide by we would need to figure out how to add some spacing. So we're getting a quarter of it, so we have 3/4. Let's do something that's easily divisible, right? If I do 0.4, that leaves 0.6 remaining. But it's not centered, but it will be if we do this, I think. So plus 0.3. Yeah, so now it's centered, but we don't want it to tile. It's like whatever is remaining, if we want the center one to be centered, um, we might be able to just hang on. Instead of doing it like that, let's do it like this. Select, invert select, feather, 5, delete, um, move the whole thing up a smidge. Save, cancel file, export to our file, back over to Unreal, import. That's better. So far, I think point 4 and point 3 have been the best. But it might actually need. Okay, so let's see. Point 1, point 4, 5. Recenter it. All right, so let's figure out how to. Wait, did I update this? Just gotta make sure I updated that. Let's figure out how to clear out the top and bottom. Just render a consistent color. So, coworker probably know the answer to that question. UE5 material mapped onto a cube. I want to move. It is additive. I want to make it so that the top and bottom faces cube are completely transparent. And I guess we could also just do it with some planes more simply. Like if I just did a plane. Let's do it like that. 4, 0.4, 0.3. Now we can go into our blueprints, go into our gravity influence zone box simple, um, viewport, add a plane, here, plane, 1, 0, okay, let's make collision off. No collision. Turn it all the way off. No collision or trace responses. We don't want this interfering with our actual collision. And now snapping, 10-degree snapping. we need to do, hang on, our material. Two-sided. Save it up. Now, pilot. Scale it. How big is this guy? 10, 10, 10. It's currently, okay, 0. It seems pretty aligned. So let's go ahead and 90 this and lock this 10. That's too big. 5, 6, 7, 6.5, 6.4. Okay. And now we're just gonna negative. Shouldn't this be like stretched out the entire length of the thing? Okay, we'll figure it out. Figure it out later. But there's some basic indicators for those. These are more just like debug things. Stop. Back to gravity direction indicator. Let's tone it down. Okay, now, likewise, save this. Let's go into our sphere influence zone. Actually, instead of doing it this way, it might actually be easier to just copy, paste. All right. Unlock the scale. Okay, so we'll do 2, 2.5. And then here, 3.2. Okay. Move this up. Here, move this to 0. Rotation, 90. Nope. Yeah, this looks. We need like a. We actually need an instance. Instance will do. Um. Scale. Offset. Save it. Back to our instance. 1, 0. No, no, no. 0, 1. And now we can go back into our directional sphere. Changes out for the instance. Likewise, perfect. Okay, and then we can just make uh, copy. Can I group these? Copy, paste. I think it was 160. Yep. And now I can get Rotation. Um, 'That seems about right. And then I think we just need what, one more copy? It's the 0. Seems about right. Seems about right. Collision. No collision. Hold up. Good enough. Not too bad. Like, it's obviously visually confusing when there's a lot in the scene, but it's really just to have one or okay. So and then um, I mean, these are kind of just the demo objects. We can always. I think it's fine. These gravity boys are not scaling. I think they need to be a child of the zone so that they scale with it, and then likewise, children of the zone. Oh, they're still not working. Well, we'll have to figure that out. But pretty happy with that. Yeah. And now we can kind of visually see. Landed on the. Nope, it came back around. It's orbiting. Oopsie. Cube, come home. Oh no. Hit the gravity elevator. All right, two more things I want to do. We're gonna make one more material. It's gonna be very simple. Direction indicator instance. Um, gravity direction bounce. Additive. Vector parameter. Color. Vector green. Two-sided. Unlit. Two-sided. Default lit. Let's just do this. Very simple stuff. Excuse me? That's a little better. Likewise over here, we're going to want a color scalar for intensity. One, zero, by multiply this. All right, and then finally, a bit more sphere. Like this, add a sphere. Scale should be reset scale. Reset. What? No, that's wrong. This 10. Nope, that's too big. 6.4. Nope. 4. Oh, I see what's wrong. You want to add it to the gravity zone. It should be pretty close. We'll take John's material. Collision. No collision. File. Finally, let's go back over to our this too high, 0.02. All right, great. Let's add the same thing to the from a teeny tiny visual indication of the boundaries. A little bit more intense than that. Okay, and then back over to gravity direction indicator. This is fine. It's going to be the Q. Pretty good. I think okay, so it's just 0.64. Perfect. Boundary. Perfect. Compile, save. And let's go ahead and add debug colors to these. So we have base gravity field here. We're going to add debug color. color. We're going to add debug translucency as a float type. And then likewise, debug color. Debug translucency. Make this a linear color. Dynamic material instance. The material. This will be the boundary material. No, no, no. Shit. That material. Debug color. It's just color, right? Color intensity. Okay, great. Actually good. Color. Scalar. Intensity. All right, excellent. And then I gotta do this one more time. Great, and it does allow us to set multiples, which is exactly why I was trying to set it up like this in the first place. So that's really good. Okay, and then let's go ahead and create a second material instance. This should be gravity direction bounds, gravity direction indicator. Which one is this? Gravity sphere. We use the instance for that one. And then we just want the same block of logic right here. I think I named them the same thing actually. And then direction material. Set material. Direction material. Kind of like that. We can just do this. Alright, so now select this guy. Let me select red. Beautiful. Alright. Awesome. Let's set up some defaults. Oops. Shit. Zone. Take the color. Default color is gonna be like green for this. Default intensity 0.1. Compile that bitch, and then gotta go do the same shit. You can copy this entire block. So in here, get the cube, get the indicator planes, the cube into the bounds, switch this to instance to the original material, plug this in here, set material. Bounds material. Instance dynamic. Like so. So, and then bounds material. Plug this in here. One more of these. Plug this in here. Oh shit. Tie up the laces. Right, compile. It doesn't like that because this needs a target. Compile. And then finally, we go here. We set our default value to green. Default intensity to 0.1. Pilot. Beautiful. All right, awesome. Now, these are like the the defaults. You would override these most of the time for your custom gravity, right? Like you would make one if you don't need all this stuff. You could make one of these that overrides the custom gravity component that only has the collision sphere, but it is nice to be able to see at a glance. Wait, why am I down here? What? What has happened to me? Oh, I know why. Okay. Yep. Let's go here. Collision. No overlap events, no stepping up, and no collision. Save it again. Now I'm still confused as to why the gravity elevators are not scaling. So we have a little bit of work to do, but this is definitely really cool that you can see kind of what the gravity do. What that gravity do though. All right, let's now we can kind of fuck around. So this one can be green, this one will change to blue or like pink. Um Understand. So I got to figure that out. We got to figure that out. Um, do like light blue for this one and purple for this one. I think that's pretty good. It doesn't have to be super fancy or anything. Just nice to have a kind of a visual indicator of what these things are doing. exactly when you're gonna get sucked up. I was trying to punt that. Punt. Neat. Very cool. So we want to do a little bit more work with the default zones. This might be a good plugin to put out. What up, dude? Okay, so I haven't done death animations yet because I want to like do a deep dive on that when I get to it, which means that I want to do like ragdoll and bullet impact animations. So I haven't done that yet. I've been working on the gravity system, and now I'm just kind of polishing up the gravity system and putting the finishing touches on it. I might. I'm considering this is like a very like small amount of code, basically, or a small amount of implementation. It might be a good plugin to put out to just do the gravity system as a plugin and the projectile system as a plugin. But if I want to do that, I want to polish it up. So I've added some debug indicators to the gravity fields, the default ones, and that's kind of what I was working on this morning. It was just adding some visual indication of what field you're going to get affected by. I wonder if I could. I wish there was a way for me to show the priority. So I added in like the materials and stuff to add these little like boundary and gravity direction indicators to my default box and sphere gravity zones. And we can turn them off as well if we want. So like if we went over here, we can set this to 0 and it won't do it. Set it to 1, it'll be really intense. Just so we can fully see what we're working with here. So now when we punt one of these into that zone, oh, and that's the other thing that like you probably didn't see if you were watching last night because after I got off, I was curious if my static mesh implementation was correct because we're applying this to the character model, which has its own custom logic. Because like with physics objects, like with static meshes, it's actually way simpler. We just have to apply the gravity force. But with the character model, the orientation of the character model has to change because if you want to be able to walk on something, your character model down has to be facing towards the center of gravity, or else you won't be able to walk on it. Um, so I fixed this to basically work for the character model, but I wanted to test my static mesh implementation. Uh, and what I ended up like the character model was actually the most complicated because we had to do a bunch of complicated calculations to figure out like the frame of reference by the character. But for things like static meshes, we have a second case, if I can find it. Let's check our gravity zone, our gravity component. So this is the case that's applying the gravity of the player up here at the top, and also applying the dampening. But for the other physics objects, they have built-in dampening, and all we have to do is add the gravity vector as an impulse to them. So this is supposed to apply to static meshes. So I wanted to test that out last night. So what I did, I went ahead and selected the stupid OBS not showing my cursor in the viewport bug is really annoying. Okay, so I selected these guys, and all we have to do to make this work is we have to add this gravity actor component to whatever we want the gravity zones to apply to. So I added this to all these little chamfer cubes that come default in the stage. And now, I mean, you can already see it working because that one was in the other boundary, but if I punt this guy over here, he starts getting affected by that gravity. I punt this guy over here, and then I go over here. Now we're in this gravity. If I punt him at the sphere zone here, he'll start falling until he touches the sphere zone, and then he'll get sucked in by that. Where's the last one? There it is. Should add some lights, some better lighting here. I'll actually make a sample stage, not just an override of the existing one, but like a sample stage that demos all this stuff. Maybe later today. I'm gonna have to get some lunch here pretty soon. But you can see he's in like a little bit of an orbit until he touches down. If you hit it just right, you might get an orbit. There he goes. And punt these guys back out of this zone. And go to our bigger cubes over here. Punt one there, punt one there. And we can kind of watch them get affected. And now we can actually see our gravity elevators too because we have the debug on them. Although I've got to figure out why the... I have to figure out like tiling correctly for this direction texture, because you can see that they should have that little direction texture down there, but they don't because it's just in the middle. But if I jump down to here, land on this guy, we can see our gravity elevators. And let's grab this box. Oops. Grab this box and kick it over here to the gravity elevator. Oh, he touched it. It might not be enough though. No, he's gonna oh, no, he made it. I think he made it. Yeah, he made it. So our cubes are over here, so we're gonna drop down over here. And obviously this is pretty busy, but like it's a debug mode, you wouldn't usually be drawing the actual zone indicators. And he just gets shunted over there. And now he's on that planet. Pretty neat. And the fun part is all of this can affect the projectile system we made as well. So I can make it so that like if I shot a gun from this planet, I get bullet drop based on the gravity zone I'm in. I don't think I would apply the zone checking for the individual projectiles themselves. I would probably just snapshot the player's gravity when they shoot it, just because that would probably be really expensive to have to query thousands of projectiles worth of gravity. If we just snapshot the gravity, then the projectile manager can handle it fine. And in most cases, I think that's all you would need, because like you're generally not going to be in a situation where like you're jumping from planet to planet with overlapping gravity spheres, right? Oh, there's one more thing I need to add to this level. I want to add a moving platform with a gravity zone on it, and then we have to figure out how to attach the actor to it when you step into it so that you're moving relative to the component you're standing on rather than to the world, because that's going to be crucial for making vehicles. like vehicles that you can walk around inside of while they move around. So that's like the last little piece that we need to make a demo for and figure out from our blueprint perspective. And then I think the whole system is basically done. Because like when I join a gravity field, it should be moving me like relative to the field so that like now if this field is moving while I'm inside of it, I move with the field. Um, and that's going to be pretty important because I want to use this for like spaceships and shit that you can walk around inside of. But I mean, this alone is pretty fun actually. Just like fucking with the debug mode is actually kind of fun. So like you could probably also make a game with just like a bunch of wonky gravity and have fun that way, you know? Boop boop. It's gonna orbit a few times before touching down. Where's the other sphere? There it is. Pretty cool stuff. It was fun. Yeah, I like making any of your boss yet. Either of you dealt with favors of AI like making enemy or boss yet? Okay, so not really, but sort of. The first thing I did, like literally the first project I tried to make, was like a little shitty horror game, like this type that people churn out, right? It's probably the easiest thing to make because the boss AI is usually really simple and there's usually not like combat. Like you don't have to shoot it. It's a horror game. You're just running from it, and it kills you if it gets you, right? So what I have done is make a little monster that wanders around in random directions, and then he has a sight cone and a hearing cone, and if he hears something, he will start turning towards it, and if he sees something, he will start chasing it until he hasn't seen it for like 2 seconds or something like that. And I did do that. Super ultra simple, no navigation mesh type stuff. So like, if you went on the other side of a box, he would just like run straight at the box until he couldn't see you anymore, and then stop and wander around and things like that. But I just made him like 1.5 times the speed of the player, something, or like slightly faster than the player, and just a simple like sight cone based trigger that would cause him to chase. Um, his chase logic was literally like, what's the player location? What's my location? Face the player location, move in that direction, and that was it. So like that's as far as I've gone on like AI. I think for like realistic shooter combatant or realistic like smart AI, it would definitely be a big challenge for sure. You can see the edge of it right there. If I touch that, I'll get sucked down to the planet. And this one is a little bit further in because it's not super perfectly oriented. Like I said, I'm doing all this in the like default level. At some point, I'm gonna make a new level and like just put the kind of example use cases of everything together. And then I might build the project into a plugin, maybe, because it seems like this would be a pretty useful plugin and pretty easy to use. Not a ton of code, so like a good use case for it. It's fun. It's fun just fucking with it. No. All right, I'm out. I'm gonna try just like scooching this thing into just barely touching this. There it goes. That was the wrong elevator. This one. Yep, there goes. All right. All of this one is blueprint based. Well, no, that's not entirely 100% true. It's operating off of a tutorial, a baseline tutorial that was created by the like actual Unreal staff that's on their website. And that tutorial has you setting up a gravity controller, basically C++ class. And so that part is not blueprint based. That's the only C++ change. Is the addition of the gravity controller. So I've got this is all material stuff, texture and materials. I've got the two demo, basically simple gravity zones. The fun part, I've got the base gravity influence zone. This doesn't have any implementation. So like the fun part of this is that you can implement these in however you want. So like you can do more complicated gravity. Like right now, these are just like I think this has linear fall off, but actual gravity is exponential fall off. So like that would be one improvement I could make if I was doing it for actual planets. I would do exponential fall off. Another thing is that this thing's fall off is based on its center location, which means that if my baseline gravity for these spheres is Earth gravity, we're going to be at low gravity because we would only hit Earth gravity at the very center of the sphere. But instead, what we could do is, and I can demonstrate that. Instead, what we could do is we could define like an inner radius at which you hit max gravity and then blend between those. I just haven't done it yet. But you can see that like my jump is like a low gravity jump when I'm on these spheres, and that's because of the fall off function I was just talking about is linear based on your distance from the outside of the radius of the zone and your character's distance to the center of the sphere. So like character distance to the center divided by radius is the fall off function we're using right now, which is really simplistic. Um, if we defined a radius and we set it to the same size as the sphere, then we would have full Earth gravity at the surface of the sphere, and it would fade to low gravity as you like leave. So like that's something that I could do, and then I also want to like get a vehicle example in place, but because it's all very extendable, like all that stuff would be pretty easy to set up as its own like little custom implementation. So you've got the gravity component. You attach this to any actor that you want, any actor that has physics enabled. you can attach this to, and it will start applying the gravity influence zones. I have two demo influence zones, some materials for like basically rendering the kind of indicator stuff, and then um, this gravity controller class and these two third person classes. Although I think this is out of date now, I need to migrate some of the gravity logic from this guy back into this guy. I would probably just like leave the third person shooter stuff out and have like the base, and then this would be like my own implementation, because this is going to be implementation specific. So yeah, I need to make sure that this guy is up to date with all the stuff that this guy has. So it would be like probably this class, this C++ class, and this folder, and that's it. So it's not like super crazy complicated. And then the projectile manager is also pretty simple. That could be its own little, and this really is entirely blueprint based, and this could be its own little package. Although I'm using this military weapon plugin, so that's a dependency for this one. So for this one, it would be like these three folders. Yeah. I know there is. It's probably doing exactly the same thing. We can look at it actually. Let's look at it. Is it free? I don't think it was free. Jesus Christ. $30. Oh, and I haven't done anything with multiplayer, so I'm not sure how to implement that. I mean, it would probably be fine. There you go. Directional planet gravity for free right here. Compatible with simply use gravity control, add gravity movement component, pawn character. So yeah, you could absolutely get a plugin that already exists for this. So maybe there's no point in publishing it as a plugin, but it is cool. Well, I mean, we do have the one C++ class. I would almost say having it all in C++ is actually an advantage. Yeah, because like there's no way to do it without like this is like all of this stuff, right? All of those other plugins are all going to be built on this tutorial. All of those are going to be built on this. And as a part of this, you need the you need this C++ class. So header code. It's like about 100 lines of code. You got 30 lines in the header and another 80 in the gravity controller. So like they all got to do this. Now, one thing that that other plugin may or may not have is the work that we did to make the animation blend spaces work properly with the character model. because like it's very simple to make the default actor run around and stuff. But as soon as you want to do stuff like looking up and down and having it like actually animate on your character properly, like this took me like a couple hours to figure out, right? And then likewise, if you want to use different blend spaces that are like directionally based, like z-axis spinning type stuff, you have to do the math to move all of those calculations into the frame of reference of the character. And I somehow doubt that it has that stuff. It probably doesn't, because it's more like, oh, I want to use this character, but also with all the like third person animations that I set up in the other project. So I'm going to need to calculate like z axis as a float, right? Like my direction indicator for my animations needs to be a float, not like a vector. And my up down pitch needs to be calculated as a float, not a vector. And to do that when your rotation and camera and like controller orientation and aim orientation are all changing because you're walking around a sphere planet, is where like the lion's share of the time to make this was spent, because like that math is not trivial. Yeah, fuck them, right? It might be a like I haven't released anything on the marketplace. It might be fun to just figure out that process. But anyway, I'm gonna go get some lunch, walk my dog, cook some burgers. I'll be back later on this afternoon. I might play some Path of Exile 2, and then later tonight, I want to implement a moving platform with custom gravity. So a platform with a gravity area parented to it, um, just like a simple cubic gravity zone that moves around the stage in a circle that we can jump on and ride around. And what I'll probably do is have it do like, instead of just riding around the stage in a circle, like instead of just riding around the stage in a circle, what we're gonna want to do is have it like, we'll have a platform where you can get on it here, right? It'll ride around in a circle, but about halfway through, we're gonna have it like flip over so that it's upside down, and then come back around, and then flip over so it's right side up, and then come back to the platform. And that'll be a proof of concept for like a vehicle. So if we can hop on that, ride it, have it flip us upside down, and have the gravity hold us on it, have it ride around upside down, and then flip back right side up, then I think we're in like good shape to make a vehicle. So yeah, later guys.